Okay, we're on the end of 4.1. Last page. 4.1, last page notes. Linear speed. Linear speed is your speed heading in a straight line. It's what you drive. Miles per hour is something you drive. Centimeters per minute. It's going to be a distance divided by a time. Tells the actual distance covered. So you're going to have distance over time. This is what you're used to, linear speed. I was running in meters per second. I was flying in kilometers per hour. So anytime they ask you about linear speed, it's basically how fast are you going. Angular speed is going to be measured in degrees per second, radians per second, revolutions per hour. Tells the angle at which the object has been rotated. So it's going to be how fast are you traveling around something, and that might be how many degrees are you traveling, or how fast are you traveling around a circle, and of course that could be in degrees or in radians. The thing about revolutions is you got to remember 360 degrees are equal to 2 pi radians, but they're also equal to 1 revolution. So 1 trip around a circle is a revolution. And then all of these things, very importantly, are equal to 1 circumference. So we're going to use dimensional analysis, and we're going to be able to go between angular speed and linear speed and back again. And you can use any of these conversions straight up to find whatever it is you might be looking for. It's a good time. So we say a circular mobile above a baby's crib makes 5 revolutions per minute. So that's currently an angular speed. 5 revolutions per 1 minute. What is the angular speed in radians per minute? All I need to do is get rid of revolutions and move to radians. Here's my revolutions, there's my revolution. 1 revolution, 2 pi radians. My answer is revolutions cancel out. I'm left with radians per minute. 10 pi radians per minute. That's it. Isn't that wonderful? Dimensional analysis. What a wonderful, wonderful tool. If the tires of a Ford Taurus have a diameter of 26.16 inches. I see diameter. I see diameter. Diameters are a problem because we usually like radii, but you can divide by 2 if you want. If the diameter is 26.16, then the radius is 13.08. Find the speed of the vehicle in miles per hour. I'm going to miles per hour from revolutions per minute. I'm going from an angular into a linear. To go from angular into linear, you have to pass through circumference. Must. That's the only way you can get from revolutions into, remember, 1 revolution is equal to 1 circumference. That's what gets you from angular trips around into apparently I need to sign into Google Drive. How annoying is that? I'm ignoring it. Good luck. So we're going to go from 800 revolutions in 1 minute, and we want to go to miles per hour. I'm going to take care of my minutes and hours first. 60 minutes in 1 hour. Boom. I've got my hour. Next, I need to take care of my, what's that? Equals, it's times. I need to take care of my revolutions and 1 circumference. Now, 1 circumference is going to be equal to 2 pi r or pi d. 26.16 pi. And that is inches. So I've got this 26.16 pi inches, 1 revolution. And now my revolutions are gone. And now I got to go inches into feet. And then I've got to go feet into miles. If you don't remember that 5,280 feet are in 1 mile, well, I'm not sure what I'm going to do. Let's take a look at what we got here. My feet go away. I've got miles right here. I'm going to go, if you take a look at what I have on the top, I got 800 times 60 times 26.16 pi. And on the bottom, I've got 12 and 5,280. You have to be careful when you're typing this stuff into your calculator. You got a couple of options. You can do the 800 times 60 times 26.16 pi. And then make sure that when you're dividing, you need to put that in parentheses, 12 times 5,280. Or you can understand that you're dividing by both 12 and 5,280 and do the double division. Either way you swing it, you're going to get, when you do the math, 62.26. That is miles per hour. And that's a reasonable speed for the Ford Taurus to be winding it out. Good stuff. Good stuff. So I swing over, and I think, let me just look real quick at what the next problem says. Compare that to a Dodge Charger with 28.63. I'm gonna make note that that diameter was 28.63, because really nothing is going to change except for the fact that we move this to 28.63. So really, right here, I can insert 28.63. So you're going to do the same thing, 800 times 60 times 28.63 pi, divided by 12, divided by 5,280, or put them in parentheses. And I get, for the Charger, I get I get 68.14 miles per hour. And it should make sense that the larger diameter going around the same number of times is going to be traveling at a faster speed. So you got to remember, when you're doing the dimensional analysis, you're going from revolutions and radians and degrees and circumference. You can interchange through all of those, and it kind of, one of the big one goes through revolutions and circumference is how you get over and back.